Very good morning, ladies and gentlemen. This is Dr. P. Samuel, Assistant Professor of Biotechnology, INR Janaki College, Sivagasi. I am very happy to meet you all through this video lecture, and I hope you people are very safe and healthy during this pandemic. So, through this video tutorial, what I wish to share with you is few applications of marine alga. See, yesterday in the previous video lecture I have told you that marine alga are also exploited as single cell proteins, which has many applications and which has many health benefits also. And through this video tutorial I am going to explain another important application of marine alga, and that is called hydrocolloids. So, marine alga are also exploited for the production of hydrocolloids. Let us see what are all hydrocolloids, its properties, examples, their production process, applications, everything in this tutorial. Let's move on to the topic. First, let me tell you or let me explain what are called as hydrocolloids. What are called as hydrocolloids? See, hydrocolloids are substances capable of forming gel-like consistency in the presence of water. Right? First thing you should recollect whenever you came to know the word hydrocolloids is they are substances capable of forming gel-like consistency in the presence of water. Right? Hydrocolloids are often called as gums. They are called as gums. Natural colloids are derived from plants. Right? They are derived from plants. There are examples for microbial colloids which are derived from microbes. The example is xanthan gum. Right? So, as we saw just before that hydrocolloids are substances capable of forming gel-like consistent material in the presence of water. They are extracted from plants, they are extracted from microbes, and when compared to microbes, marine algal forms are much exploited for the production of hydrocolloids. Right? They are much exploited for the production of hydrocolloids, and hydrocolloids are exploited in medical as well as food industries. See, it has a wide range of applications. It is used in both medical as well as food industries, right? And here I have given two pictures. See, these are pictures taken by me during my minor research project time period. It is along the southeast coast of Tamil Nadu, particularly Adrambatinam coastal regions. There you could find colonization of brown and green alga. If you wish to pursue your research in exploiting or in exploring marine algal forms, you could visit southeast coastal part, particularly the Adrambatinam coastal regions, concerned for the isolation or collection of different forms of alga. It is a very ideal environment. If possible, go and visit there for witnessing the wonders of nature. Right? Fine. What are carrageenan? Carrageenan is an example for hydrocolloid. I told you through this tutorial we are going to see about hydrocolloids. One such hydrocolloid is carrageenan. These hydrocolloids are hydrophilic in nature. What is called hydrophilic? They are water loving. They are Water loving. What is water loving? They can readily binds with water. They can readily soluble in water. So that's why they are called as hydrophilic in nature. They are called as hydrophilic. Well, the carrageenan is linear in nature. It is linear and they are sulfated polysaccharides. They are flexible. What is sulfated polysaccharide? Another thing, it's a new term for you. Sulfated polysaccharides or polysaccharides with sulfur groups. With sulfur groups, right? It is extracted from shoreline red seaweed. So, hope you can able to recollect the name of red seaweed because it contains the pigment called rhodopsin, 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 red color pigment, and the pigment gives red color to the seaweeds, right? Members belongs to the family Rhodophyta. Fine. Carrageenan are mainly exploited in food and milk industry as thickening and stabilizing agents. Their application is quite important. They are used in food industry as well as in milk industry as thickening and stabilizing agents. We have several reports that it is also used in meat industry, meat processing units, because it is capable of binding with food proteins. It is capable of binding with food proteins, right? So, carrageenan has multiple applications. It has application in food industry, it has important role in milk industry. Added, it has also playing an important role in meat industry because it easily binds to food proteins, right? See, there are three types of carrageenan available in the market based upon the degree of sulfation. So, it is very important point. There are three types of carrageenan available in the market based upon the degree of sulfation. I told you what is sulfation. Sulf refers to sulfur group, iation refers to addition, right? Addition of sulfur group is called sulfation. Where the sulfur groups are added? Sulfur groups are added to the carrageenan. What is carrageenan? Carrageenan is a hydrocolloid. What is a hydrocolloid? Hydrocolloids are substances can able to form gel-like consistency in the presence of water, right? Well, next slide. What are the varieties of carrageenan? This is very important thing and this is very important slide. Let's see what are all the varieties of carrageenan in detail. So, I told you that the varieties are based upon the degree of sulfation, right? See, in the market there are three principal types of carrageenan. They are kappa carrageenan, which has one sulfate group per disaccharide, right? I told you the different saccharide units that makes up the carrageenan molecule in the next slide. See, kappa carrageenan has one sulfate group, iota carrageenan has two sulfate group per disaccharide, and lambda carrageenan has three sulfate group per disaccharide. This is very important thing. Please keep it in mind. Please remember the differences, right? Don't confuse yourself. Kappa carrageenan has one sulfate group per disaccharide. Iota carrageenan has two sulfate group per disaccharide, and lambda carrageenan has three sulfate group per disaccharide. See, another interesting thing, carrageenan is vegetarian, right? Carrageenan is vegetarian and it is a very good alternate to gelatin, right? We can also use carrageenan as a substitute in making confectionaries, right? 100% pure vegetarian confectionaries, right? This is the advantage of carrageenan. Let's move on to the next slide. What are all the properties? See, I told you that it is a flexible polymer. It is a flexible polymer, and carrageenan is able to form different forms of gel based upon the temperature. See, the formation of gel is influenced by the temperature of the area, right? So, in the presence of water, carrageenan will definitely form gel, but the type of gel, whether it is complete gel or semi-solid, the consistency of the gel is influenced by the temperature of the molecule or temperature of the environment in which the polymer is present. So, it is a high molecular weight polymer. Remember in mind, it is a high molecular weight polymer. It is made up of repeating units of galactose and 3,6 anhydrogalactose. I told you in the previous slide, carrageenan is a disaccharide. The repeating disaccharide makes the carrageenan molecule into a high molecular weight polymer. The two different types of disaccharides are galactose and 3,6 anhydrogalactose, and these disaccharide units are bounded by alpha 1,3 and beta 1,4 glycosidic linkages, right? Glycosidic linkages are linkages between sugar units, right? So, alpha 1,3 and beta 1,4 are glycosidic linkages which connects the disaccharides into a polymeric substance, and the variation in gelling nature is due to the number and position of ester sulfate groups on sugar units that makes up the carrageenan molecule, right? Another important property, variation in gelling nature is due to the number and position of ester sulfate groups. Remember, it is a flexible polymer. It can able to form different forms of gel based upon the temperature in which the polymer is present. It is made up of repeating units of two sugar units called galactose and 3,6 anhydrogalactose. These disaccharide units are bounded by or linked by alpha 1,3 and beta 1,4 glycosidic linkages, right? We will move on to the next slide. This is an important area, production of carrageenan. See, it is a very important portion. The portion will be definitely expected in section C, right? See, carrageenan, there are three principal types of carrageenan I told you. One is lambda, kappa and iota, right? So, this variety is based upon the number and position of sulfated groups. In the market, there are two different varieties of carrageenan are available. One is semi-refined carrageenan and refined carrageenan. So, these are all the two principal products or forms of carrageenan available in the market. Let us see the steps involved in production of refined carrageenan, right? So, you may ask, sir, what is the application of carrageenan? Why it needs to be produced, right? See, in the previous slide we were discussed about single cell proteins. You may ask, sir, what is the necessity to produce single cell proteins? We have a concrete answer that single cell proteins are an efficient protein supplement which help us to escape from a protein deficient disease called kwashiorkor. It reduces obesity, it reduces stress, it reduces the accumulation of cholesterol in the blood vessels, right? There are many applications. Like that, carrageenan also has wide range of applications. It has an important role in food industry, it has an important role in medical industry, it has an important role in pharmaceutical industry, even it has important role in meat industries, right? This is why people are trying a lot for the production of carrageenan across the world. The leading producer of carrageenan is Indonesia, right? Keep it in mind. The leading producer, world leading producer of carrageenan is Indonesia. They are producing tons and tons of carrageenan per year. They are supplying the carrageenan to every part of the world. They are the leaders, right? Fine. From where this product is extracted? Another important question you may ask, sir, from which alga the product is extracted? I told you the alga is Chondrus crispus, right? I repeat, Chondrus crispus. Commonly it is called as Irish moss. IRISH MOSS. Irish moss is the common name given to the algae Chondrus crispus, right? So from this algae, carrageenan molecule is extracted. Carrageenan polymer is extracted, right? What are all the steps involved in production of carrageenan? It is very simple, but keep it in mind and kindly note down the steps I am telling through this lecture. Cleaning. The first step in the production of carrageenan is cleaning and washing. What is cleaning and washing? Right? While we go for sampling with an intention to collect algae, we can collect it and we can bring it to the laboratory. So before it is subjected to exploited with respect to the production of carrageenan, it has to be cleaned. It has to be cleaned. See, this is the raw algal material we have collected. See, you could find there are dust particles associated with the algal units. The sand molecules are adsorbed to the surface of algal biomass. After washing, look at this picture. It is free from dust and other adsorbing units. See, it has to be removed before it is subjected to exploitation with respect to the production of carrageenan, right? So cleaning and washing is very important step, right? So it must be done in a careful way. After washing with water, after the removal of coarse waste materials, coarse in the sense COARAC, right? Don't think it as COURAC, it is COARAC, right? Coarse waste units adsorbed to the surface of algae. It is subjected to alkali treatment and extraction. Alkali treatment and extraction. What is alkali treatment and extraction? See, the algal biomass or the feedstock material is boiled with alkali material, probably sodium hydroxide. So this will soften the algal tissue, right? An alkali will soften the biomass so that the carrageenan, the polymer trapped in the algae, will comes into the aqueous environment, right? Mere boiling in water doesn't make any change in the algal biomass. So to extract the trapped form of carrageenan from the algae, we are using an alkali, right? Alkali softens the tissue and makes the polymer to release into the aqueous environment. So followed by alkali treatment and extraction, it is filtered. It is filtered because during this alkali treatment, the biomass is broken down into small pieces, right? So still there are possibilities for the presence of coarse materials along with our product. So it is very necessary for us to separate the product from the waste. So to do it, we can go for a centrifugation process, right? Or else we can go for pressure filtration. Under pressure, the material is filtered so that waste are separated from the product, right? Next step is recovery. Recovery, which means concentrating our desired product, so called carrageenan, from the waste. Next slide. Gel pressing and process and drying and milling, these are all the steps remaining. What is gel pressing? Once the gel is obtained, right? Wait. At the time of recovery, we will obtain the carrageenan in the form of gel, right? In the form of gel sheet, right? Once it is obtained, it is pressed. It is pressed. Why it needs to be pressed, right? Because there are possibilities for the presence of water molecules in the gel, right? So to remove the water molecules, the gel is pressed. The gel is completely pressed with suitable machineries. The final step, it is the water free gel is subjected to drying and milling process, right? Drying and milling process. So during this process, the water free gel is completely dried. It is completely dried and concentrated into powdered form. See, this is the powdered form of carrageenan, right? And this is the final product, right? Carrageenan is in the form of powder. It is transformed into gel in the presence of water, and the nature of the gel can be determined by the water, right? This is the meaning of hydrocolloid. So hydrocolloids are substances. They are substances. They are powder-like substances which can transform into gel-like consistent material in the presence of water, right? Just try to recollect all the things. What is a hydrocolloid? Hydrocolloids are gel-like substances. Hydrocolloids are substances able to form gel-like consistent material in the presence of water, right? One such hydrocolloid is carrageenan. It is extracted from an algae called Chondrus crispus, which is familiarly called as Irish moss. In the world, Indonesians are the leading producers. They are the leading producers of this polymer. They alone supply this polymer to rest of the parts of the world, right? And there are three principal types of carrageenan are available. One is kappa, second is lambda, and the third one is iota. And based upon the purity, there are two types of carrageenan are available. One is semi-refined carrageenan and second one is refined carrageenan. Carrageenan molecule has wide applications. It is preferred in medical industry, it is preferred in pharmaceutical industry, it is preferred in milk industry, even it is preferred in meat industry, right? So it is very clear that this polymer, hydrocolloid, has potential economic importance. That is why it is produced by the people, right? It not only supports their economic status, it also support the economy of the nation. right? While we go along the southeast coast of Tamil Nadu, particularly in Adirampatnam coastal regions, you could find many people involved in collection and production of this polymer, right? Collection is very, very important. Once after collecting it, they are segregated based upon the quality, right? They will supply the raw material to the industries according to their needs. So it is a wonderful business. But we should know some background about algae, its collection process and everything, right? It is not a simple thing to be readily jumped into the production process of carrageen. So before that we should know many basic things, right? What I am telling you is simply theoretical part. So for practical application, at least once you should visit the southeast coastal regions of Tamil Nadu, particularly the Adirampatnam coastal regions. There are many people are involved in the production of carrageenan, and they are also involved in collection of different algal forms, and they processed it, and they even supply the algal forms to the market, right? So we'll come to the end of the slide. Thanks for your patient listening, and for any queries please do mail me. My email ID is drsamuelpampandian@gmail.com, and I am available in the number 8695959994. You could also access into the link which I have given here, and this is the link available in SlideShare. The PowerPoint presentation is available. You could visit and you can refer the presentation for your future studies.